Okay, so we're going to look at what are called sinusoidal functions. So that's the sine and cosine, and the form that they have. Now, we've done some of this in the past where we were doing transformations, so we may have some kind of inclination in what's going to happen here. So you see how there's an A there. That's going to give you a vertical stretch. Now, we're not going to call it that, or compression, but just kind of comparing it to what we did in the past. The B, that's like a horizontal stretch or compression. Now, we're not going to call it these, so don't maybe even write this down. But this is going to represent a shift, right? Left or right, shift, left, oops, right or left. And then this is going to be a shift up or down. Okay, and the same thing's going to be true over here. All right, so the first thing we're going to look at, though, is without the shifting left and right and up and down, we're just going to look at the stretching and compressing. Compressing? Okay, so we're going to look at functions in this form and this form. Now, because of the B, that's going to either, here's a sine curve. The B is either going to squish it together, so it's like taking up less room, or it's going to spread it out, okay? So this would be, it's like a compression, and then this, like a compression, and then this would be like a stretch, right? Okay, so B is going to tell you the period. The period is found by 2 pi over the absolute value of B. Let me rewrite that. Period P is equal to 2 pi over the absolute value of B. Okay? Now, I kind of skipped over A, right? A is going to say vertically, right? So maybe our sine curve looks like this normally, but now maybe it's going to go way up and way down. So something like that would be a stretch, or you could envision a compression, okay? Remember how to find the period. That will help you with these graphs. So period, for sine and cosine, it's 2 pi over the absolute value of B, okay? I'll write that one down. Okay, I think that's all I have for this video.